to say about image processing fundamentals. I am Dr. M.KAVITHA, Associate Professor in Electronics and Communication Engineering, PSN College of Engineering and Technology, TIRUNELVELI. So this is the outline of my presentation. Components of image processing system, types of image sensors, key characteristics of image sensors, hardware, software and network, steps of image processing system. So this is the components of image processing system. We have image display, computer, mass storage, hard copy, specialized image processing hardware, image processing software and image sensors. So in that now first we are going to see about image sensor. What is an image sensor? Image sensor is a device that captures light, converts light into electrical signals. Electrical signals are converted into digital images. This acts as the first component in image processing. So the role of image sensors in image processing. It captures raw image data, determines image quality, affects resolution, noise and dynamic range. Forms the input for image enhancement and analysis. Working principle of image sensors. Light enters through the camera lens. Light falls on photosensitive pixels. Pixels convert light into electrical charge and then charges are converted into digital pixel values. Digital image is processed for further. And these are the types of image sensors. Charge coupled devices, complementary metal oxide semiconductor. Both type of sensors convert light into electrical signals and differ in performance and power usage. So CCD image sensors have high image quality, low noise, high power consumption and slower image capture, used in scientific and medical imaging. CMOS image sensors have low power consumption, faster image capture, low cost, on-chip processing capability, widely used in smartphones and cameras. Key characteristics of image sensors. Resolution, so it defined by the number of pixels, pixel size, dynamic range, sensitivity, noise level and frame rate. Color image sensors use color filter array and each pixel detects one color, either red, green or blue. Applications of image sensor. Digital cameras and smartphones, medical imaging, satellite and remote sensing, industrial inspection, computer vision and AI systems. Image processing hardware. It consists of a digitizer and performs other primitive operations such as arithmetic, logic unit, arithmetic and logical operations on the images. Computer, that is a general purpose computer used for the applications. Software. So it is consists of a specialized models that perform specific tasks. A well-designed package also includes capability for the user to write code as a minimum and specialized model. More sophisticated software packages allow the integration of these models. Mass storage. So this capability is a must in image processing application. An image of size 1024 into 24 pixels. Intensity of each pixel is an 8-bit quantity, requires 1 megabytes of storage space. If the image is not compressed, so it should be compressed for the short-term storage during processing. Online storage for fast retrieval. So magnetic tapes and discs also used for the mass storage. Image display. So image displays in use today are mainly color TV monitors. These monitors are driven by the outputs of image and graphic display cards that are an integral part of the computer system. Hard copy devices. The devices for recording image includes laser printers, film cameras, heat sensitive devices, inkjet units and digital units such as optical CD-ROM disc. Films provide the highest possible resolution, but paper is the obvious medium of choice for written applications. Networking. So as we all know, if you want to transfer the data from one media to wherever we want to access the images, networking is very much essential. So this is the key consideration, and bandwidth is the requirement for the networking of images. So next one we are going to see about the image sensors in the single image sensor. This is the image of a single image sensor where the light energy is fallen on that one, and the material captures the image, and the final output is in the form of voltage waveform. So these are some type of image sensors: line sensor and array sensor. Image acquisition using linear and circular strips. So using linear strips, one dimensional. So here the sensor moves with linear motion across the imaged area. For each small increment of motion, one image line is captured. Multiple scan lines are combined sequentially to form a 2D image. This method is commonly used in flatbed scanners, industrial inspection and satellite imaging. Circular sensor strip. A circular arrangement of sensors surrounds the object. An X-ray source and sensor ring rotate and move linearly around the 3D object. Each rotation captures cross-sectional images of the object. These slices are processed using the image reconstruction techniques. The result is a 3D object used in computer tomography scanning. So the next one we are going to see the fundamental steps in image processing. So the general one is the knowledge base. So the first one is image acquisition. The next one we will do with the image enhancement, and then next image restoration, then color image processing, and then wavelets and multi-resolution processing. The next step is compression, morphological processing, segmentation, and then representation and description. The last one is object recognition. These are the various fundamental steps in image processing. So not necessarily we do all the steps. Depending upon the application requirements, we will process whatever the steps required. So the first one is image acquisition. So image acquisition is the first step in digital image processing. So first we have to get the image in digital form. This is done using the sensor strips on sensor arrays and electromagnetic wave light source. The light source falls on an object and it gets reflected or transmitted, which gets captured by the sensing material. The sensor gives the output voltage in voltage waveform in response to the electric power supplied to it. The example of a situation where reflected light is captured is a visible light source. So the next one is image enhancement. Image enhancement is the manipulation of an image for a specific purpose and objectives. This is majorly used in photo beautify applications. So these are performed using the filters. So filters are used to minimize noise in an image. Each filter is used for a specific situation. To simplify the process, we perform multiplication in the frequency domain, which gives the same result. We transform the image from spatial domain to frequency domain using discrete Fourier transform, and then go back to spatial domain using inverse discrete Fourier transform. Some filters used here are Butterworth filter and Gaussian filter. And low pass filter, high pass filters are also used for removing the noise and gives a blurring effect. High pass filter is used to sharpen the images using spatial differentiation. Examples of high pass filters are Laplace filter and high boost filter. There are other nonlinear filters for different purposes. A median filter is used to eliminate salt and pepper noise. So the next one is image restoration. Image restoration is related to improving an image, but image enhancement is more subjective, whereas image restoration is objective. Restoration is applied to a degraded image to recover back the original model. So we can estimate the degradation by observation, experimentation and mathematical modeling. Observation is used when you do not know anything. In experimentation, we find the point spread function with an impulse with a similar setup. In mathematical modeling, we even consider the environment at which the image was taken, and it is the best out of all the other three methods. Color image processing. Color image processing is motivated by the fact that using color, it is easier to classify. The human eye can easily see thousands of colors than shades of black and white. So it is divided into types pseudo color or reduced color processing. In pseudo color processing, grayscale is applied to one color. It was used earlier. Nowadays, full color processing is used for full color sensors such as digital cameras or color scanners. So here color image processing, we have various color models like RGB, CMY. RGB is red, green, blue, and CMY is cyan, magenta, yellow. HSI, hue, saturation, intensity. Different color models are used for different purposes. RGB is understandable for computer monitors, whereas CMY is understandable for a computer printer. So there is an internal hardware which converts red, green, blue into cyan, magenta, yellow, and vice versa. But humans cannot understand RGB or CMY, they understand HSI, that is hue, saturation and intensity. HSI color space is a very important and appealing color model for applications in image processing. The HSI variety model addresses each tone with three parts: intensity, saturation and hue. Hue is a color component that describes a pure color, that is pure yellow, orange or red. Compression. Compression deals with decreasing the storage required to the image information or the bandwidth required to transmit it. Compression technology has grown widely in this era. Many people are knowledgeable about it by Common Image Extension JPEG, Joint Photography Experts Group, which is a compression technology. This is done by removing redundancy and irrelevant data. In the encoding process of compression, the image goes through a series of stages: mapper, quantizer, symbol and encoder. Mapper may be reversible or irreversible. Example of mapper is run length encoding. Quantizer reduces the accuracy and is an irreversible process. Symbol encoders assign small values to more frequent data and is a reversible process. Morphological image processing. In morphological image processing, we try to understand the structure of the image. We find the image components present in the digital images. It is useful in representing and describing the images, shape and structure. We find the boundary, hole, connected components, convex, hull, thinning, thickening, skeletons, etc. It is the fundamental step for the upcoming stages. Segmentation. Segmentation is based on extraction information from images on the basis of two properties: similarity and discontinuity. For example, a sudden change in intensity value represents an edge. Deduction of isolation points, line deduction, edge deduction are some of the tasks associated with the segmentation. So in a particular image, if you want to detect the line or segment from the multiple images, we want the segmentation of the image as shown in the figure. So it can be done by the step called segmentation. Can be done by various methods like thresholding, clustering, superfixes, graph cuts, region growing, region splitting and merging, morphological watersheds. So here in this image, the right hand side image, we can see semantic image segmentation, instance segmentation, phenotypic segmentation. So depending upon the user application requirements, the images can be segmented. So this segmentation can be done by any of the software algorithms with the help of filters and algorithms. Using the MATLAB coding, we can perform this segmentation operations. Feature extraction. So feature extraction is also a very important important steps in the image processing. So here while we are taking the geological data from the satellite images, this feature extraction is going to help a very lot. So whenever we want to find the minerals and the rare metals present in the geographical location, we want to locate those places. So these can be done by the feature extraction technique in the image processing. So this is the next step after segmentation. So here we extract the features from images, regions and boundaries. Example of feature extraction is corner deduction. So these features should be independent and insensitive to variation of parameters such as scaling, rotation, translation and illumination. Boundary features can be described by boundary feature descriptors such as shape numbers, chain codes and Fourier descriptors and statistical moments. So this is a subjective representation of the image processing than the objective features. So here we can see the image pattern classification. So how the patterns are classified. So this pattern classification can be very much useful in identification of the image pattern for various applications in the image processing. This is also one fundamental part of the image processing step. So this we can identify the objects, suppose for example flowers, fruits or humans. So we want to categorize the images in the particular category. So the image patterns are classified accordingly. So either it can be a flower or it is a fruit or it is an animal or it is a human. So like that the images are classified according to the image pattern classification. Applications of image processing. So there are a very numerous applications are involved in the image processing. In medical diagnosis mainly image processing is used. So to detect the various diseases. Gamma ray imaging, X-ray imaging, ultrasound imaging, MRI imaging is used to know about the internal organs and bones of our body. Even in the cancer detection also the image processing plays a very crucial role. In satellite imaging is very much useful, the image processing is. So here in satellite imaging and astronomy, infrared imaging is used. So the infrared imagings are even in the daytime or in the night time also the images are captured and it can be processed for various applications. Where to find out the geological locations or to find out the according to geological locations, the materials or the minerals or the rare metals available. So to collect those data also image processing applications are used. In forensics, for biometrics such as thumbprints and retina scan, digital image processing is used. We can find defects in manufactured packaged goods using microwave imaging. So various frequency spectrums are available. So microwave or X-ray or a terahertz imaging, all image processing can be used for the different applications and in the different frequency domains. We can find information about circuit boards and microprocessor for fault detection or testing and diagnosis. Using image restoration, we can identify the car number plates of moving cars from CCTV for police investigations. Beautiful filters are used in social media platforms which use image enhancement. We can classify and identify images using deep learning models. So, artificial intelligence and deep learning is nowadays a very growing field. So, these fields are used for image processing also, either image enhancement or image compression or morphological processing or color image processing or compression. Compression is required for image transmission using the internet. So, for those applications we need to train the models. So, we can classify and identify images using deep learning models. In conclusion, a picture is worth 1,000 words and the world is filled with the beautiful pictures. To manipulate these images according to our needs is all digital image processing. And we live in the world using advanced digital image processing in diverse fields. So, image processing is generally requirement. So, as we told, a picture is worth of 1,000 words. So, according to our requirement and application, digital image processing is very much essential in the modern day technologies, and we do the image processing using the algorithms, various algorithms and the software using the MATLAB. So, we live in the world using advanced digital image processing in diverse fields. Thank you.